Hello dear learners. In this video session, we are going to learn about symmetric and skew symmetric matrices. Learning objectives. At the end of this video session, you will be able to differentiate between symmetric and skew symmetric matrices, demonstrate a matrix as the sum of symmetric and skew symmetric matrix. So let's recall whatever we know about matrices, let's just revise it. A matrix is a rectangular array of numbers or functions. The numbers or functions are called elements of the matrix. A matrix having m rows and n columns is called a matrix of order m by n. A matrix having same number of rows and columns is called square matrix. A matrix obtained by interchanging rows and columns is called transpose of the matrix. Transpose of a matrix is denoted by A dash or A t. If A is equal to Aij, its order is m by n, then A transpose will be one more matrix with elements Aj and its order becomes n by m. Now let's study about symmetric matrix. Now what is a symmetric matrix? A square matrix. Take into consideration this term, the matrix has to be a square matrix, is said to be symmetric if A transpose is equal to matrix A. For example, I take matrix A as Aij, then Aji will be its transpose and both of them are equal for all the possible values of I and j. Let me take one example here. Let this be a matrix A consisting of elements 1, 4, 5, 4, 2, minus 6, 5, minus 6, 3. Then you take its transpose, make this R1 as column 1, this row 2 has been made as column 2, row 3 has been converted into column 3. Then you can see that A transpose and A, both the matrices are equal. So in that case you can say that A is a symmetric matrix. Now let's study about skew symmetric matrix. A square matrix A, Aij is said to be skew symmetric matrix if A transpose is equal to minus A. That means if Aj is equal to minus Aij for all the possible values of I and j, you can say the matrix is skew symmetric matrix. So let's take this example of matrix A and let's calculate its transpose. You are already aware of how to make its transpose. That means you can write its first row as first column, then write second row as second column, third row make it as third column. Is there any connection between A and A transpose? No. But now if you take this negative common out, to take negative sign common, that means you are taking minus 1 common from all the elements. It becomes 0, 4, 5, this becomes minus 4, 0, minus 6, it becomes minus 5, 6, 0. Now can you see the connection? Yes, you can say that A transpose is equal to minus A and you can say this is a skew symmetric matrix. Also you can see that all the diagonal elements are consisting of zeros and all the non-diagonal elements are differing just by the minus sign. So that leads us to one more very major property of this, that all the diagonal elements of skew symmetric matrix are 0. How can you show that? So let's take Aij as a skew symmetric matrix. That means A transpose must be equal to minus A. That means Aj is equal to minus Aij for all the possible values of I and j. So put I is equal to j, that means I am talking about just diagonal elements like A11, A22 and A33. So you get AII is equal to minus AII. So, shift this to this side, it becomes twice AII is equal to 0. So, shift this to other side, this is giving you that all the diagonal elements are 0 in the case of skew symmetric matrix. So, let us move to the next result 2. For any square matrix A with real number entries, you can say that A plus A transpose is always a symmetric matrix. So, let me take B as A plus A transpose, take its transpose of the both the sides, that means B transpose is equal to transpose of A plus A transpose, take transpose term wise, A transpose plus transpose of A transpose. This is giving you A transpose, but this will give you matrix A. So, A plus B is equal to B plus A. So, you can invert them and that is giving your matrix B back here. This shows that A plus A transpose is always a symmetric matrix. So, let us study one more result. For any square matrix A with real number entries, A minus A transpose is skew symmetric matrix. Let us take C as the matrix A minus A transpose, take transpose of both the sides, that means C transpose is equal to A minus A transpose whole transpose. Take transpose term wise again, A transpose minus transpose of A transpose. So, this is A transpose minus A. So, is there any connection between C and this matrix? Yes, if you take negative sign common, you will get A minus A transpose, which is negative of your original matrix C. So, that is proving that A minus A transpose is always a skew symmetric matrix. Let us do one more result. Next result is any square matrix A can be expressed as sum of symmetric and a skew symmetric matrix. So, let A be any square matrix, then we can write A as half A plus A transpose plus half A minus A transpose. We have just studied that A plus A transpose is symmetric matrix, while A minus A transpose is skew symmetric matrix. So, A can be written as sum of one symmetric and one skew symmetric matrix. So, half A plus A transpose is symmetric because half is a scalar quantity, it is not going to affect its nature, and similarly half A minus A transpose is skew symmetric matrix. So, any square matrix A can be expressed as sum of one symmetric and one skew symmetric matrix. Let us do few questions of NCERT. Question number 8, part 1 of exercise 3.3, you are given a matrix A, this is square matrix of order 2. You are supposed to verify A plus A transpose is symmetric matrix. How will you do that? You first calculate A transpose, that means write first row as first column, write second row as second column. Then take A plus A transpose, add their corresponding elements, 1 plus 1 will give you 2, 5 plus 6 will give you 11, 6 plus 5 11, 7 plus 7 14. You are supposed to prove that A plus A transpose is symmetric matrix. So, take its transpose, that means take transpose of A plus A transpose. This is coming as 2, 11, 11, 14, which is equal to matrix A plus A transpose. So, you can conclude that matrix A plus A transpose is symmetric matrix for this matrix A. Let us do next question. For this matrix A, verify that A minus A transpose is skew symmetric matrix. Take transpose of matrix A, 1, 5, 6, 7. Then calculate A minus A transpose. Subtract corresponding elements. 1 minus 1 is giving you 0. 5 minus 6 will give you minus 1. 6 minus 5 will give you 1, 7 minus 7 will give you 0. Now take transpose of this matrix A minus A transpose. 0 minus 1 as the first column, 1 0 as the second column. Now let us take negative sign common from here. It becomes 0 plus 1 minus 1 0. Isn't it the given matrix A minus A transpose? So you can write like this. This is negative of A minus A transpose, and you can conclude that A minus A transpose is skew symmetric matrix. Let us do one more question of NCERT. Express the matrix A as sum of symmetric and skew symmetric matrix. So for that, take A transpose first. It becomes 3, 5, 1 minus 1. We have converted rows into columns and columns into rows. Take one more matrix P as half A plus A transpose. That means it is half A plus A transpose. Add them together, corresponding elements of course. 6 plus 3 plus 3 6, 5 plus 1 6, 1 plus 5 6, minus 1 is giving you minus 2. Just simplify by multiplying by half, 3 3 3 minus 1. Then take its transpose. It's 3 3 3 minus 1, which is equal to P. That means P is symmetric. Then take another matrix Q as half A minus A transpose. So subtract elements of A transpose from corresponding elements of A. 3 minus 3, 0, 5 minus 1, 4, 1 minus 5, minus 4, minus 1 and minus 1 are subtracted and giving you 0. Multiply by half, you will get 0, 2, minus 2, 0. Take its transpose. It is giving you 0, 2, minus 2, 0. Take negative common. It is giving you 0, minus 2, 2, 0, which is equal to matrix Q, and this shows that Q is skew symmetric matrix. Then in the next step, so Q transpose is equal to minus Q, that means Q is skew symmetric matrix. So now let us add these two matrices P and Q. You can recall that matrix P is 3, 3, 3 minus 1, and matrix Q is 0, 2, minus 2, 0. Add them together. This is 3, this is 5, this is 1, this is minus 1, which is our original matrix A. So you can conclude that A can be expressed as sum of symmetric and skew symmetric matrix. Let us do one more question. A and B are symmetric matrices, then show that AB minus BA is a skew symmetric matrix. How will you show that? So let us take AB minus BA and take its transpose. Solve it. We can write AB transpose minus BA transpose. You remember law of reversal, so we can write it as B transpose A transpose minus A transpose B transpose. Now you are given that A and B both are symmetric matrices. That means B transpose is equal to B and A transpose is equal to A. Similarly, this term will also become AB. Take negative common, it becomes AB minus BA. That means AB minus BA, the original matrix, negative. So, you can conclude here that AB minus BA is skew symmetric matrix. Right. So, now let us summarize this. A square matrix A, Aij is said to be symmetric if A transpose is equal to A. A square matrix A, Aij is said to be skew symmetric if A transpose is equal to minus A. All the diagonal elements of a skew symmetric matrix are 0. For any square matrix A with real numbers as its elements, A plus A transpose is always symmetric and A minus A transpose is always skew symmetric matrix. Any square matrix A can be expressed as sum of one symmetric and one skew symmetric matrix. So, with this we just end with this video session. Thank you everyone.